So, hi everyone. First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where everything is being taught to you completely in English. And as you already know, Unacademy has become the largest online learning platform for IIT JEE, and we guys here hope to make the IIT JEE preparation way easy for you. So this is a session that we are hosting for as a revision session for all 2021 aspirants. And today we'll be having a quick review part 2 of Newton's laws of motion. Before I get started with today's lecture, let me introduce myself for those of you who might not know me yet. Hello AP, how are you? Okay, so my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. And for the past almost 8 years, I've been teaching physics for IIT JEE exam. And all this teaching so far had been offline, and offline I've been associated with some of the topmost institutes in the J field. Now, I myself was an All India rank of 447 and All India rank of 192 in the two stages of the IITJ exam that I took. And I also qualified the NTC stage 2 as a student, and I was in the top 1% of the NACP exam. Now, I've already coached many students to top ranks in the IITJ exams, both mains and advanced, and I hope to continue doing that here with you guys. Okay, so how can you guys make sure that your studies are going uninterrupted and you are getting ahead in of the competition? So this is one great way to achieve that. You can get yourselves the Unacademy subscription. This subscription will give you benefits like live classes where you will get to interact with your educators on a regular basis. You also have live polls and leaderboards here in these classes, which keep them highly interactive and fun. Then you have test series and analysis sessions which keep you on your toes, which help you assess where you are standing in the competition. And of course, you have live doubt clearing sessions. So as a matter of compulsion, every fourth session in every Unacademy Plus course is supposed to be a live doubt clearing session. So with Unacademy subscriptions, your doubts are always taken care of. All right. So on top of all these benefits, you are also getting the chance to study from the top educators all across India from the comfort and safety of your. Okay. So make sure that you're getting the subscriptions, and these are the courses that you can enroll in on Plus. So there are three courses currently which are being held on Plus Unacademy Plus by the J English team for class 11 students, or even for any student who wants to study class 11 topics. So there are three courses for class 11 topics currently running, which include a detailed course on graphs, sets, and relations and functions by Abhinav sir. Then there is an advanced course on redox and equivalent concept by Rahul sir, and I myself am taking an advanced course on mechanics. Then you also have four more courses for class 12 topics currently running on the Unacademy Plus. So how you can be a part of these by following these simple steps. So first you will need to install the Unacademy app. Once you've done that, you'll need to go to the plus section of your app, select your goal as IITJ, and click on that get subscription button. Now also don't forget to take part in the Unacademy Combat. This is the most competitive gamified version of the IIT JEE. Okay, so here you can compete live. The next event will be on 22nd of November. And if you do well, you will win yourself rewards and prizes. Now you can enroll now using the code RD Live for the Unacademy Combat. So make sure you are getting there and do well and win yourself some cool prizes. Those of you following us on the J English channel of YouTube can connect with us on the Unacademy uh, channel of J English this by going to that link. All right, so without any delay, let's get started with a quick review part 2 of Newton's laws. So the first part we talked about the basics, we talked about the FVDs, we talked about how you what Newton's laws are, how you apply them, and we talked about string constraints. Today we will continue our discussion with constraints. There is another kind of very common constraint that you will encounter in Newton's laws chapter, which is wedge constraint. So what is a wedge constraint? So any object moving in contact with a wedge is restricted in its motion. So whenever a solid is in contact with a solid, so there will be some restriction of motions because of this solid-solid contact. So whenever anything is connected to a wedge and moving, then the restriction arising due to this contact in the motion of this object is called the wedge constraint. Okay, so how do you calculate or how do you identify the equation of wedge constraint? So when the motion of such an object is observed in the reference frame of the wedge, then you will realize, so in the reference frame of ground, both of them may be moving. Okay, so maybe the wedge is moving like this, or it could have moved even in the opposite direction due to some external force. But here I'm assuming that the wedge is moving in some direction like this, and the block has some velocities in x and y both. Okay, and has some accelerations in x and y both, and is moving in some random direction. Now, how can I relate the accelerations of these two? What you can do is go to the reference frame of the wedge, okay, and look at the motion of the block from the reference frame of the wedge. So from the reference frame of the wedge obviously will appear stationary. And with respect to a stationary wedge, you will realize that the only way this guy can move is either up the incline or down the incline. So that is going to be the logic of deriving the equation of wedge constraints. Okay, so you go to the reference frame of the wedge and you realize that the net acceleration now has to be along the incline, and there can be no acceleration or velocity perpendicular to the wedge incline. Okay, so this is how you will get the wedge constraint equation. So here is an example, and you can derive the wedge constraint equation very easily using the logic that I just told you. So in this example, this is a typical example of wedge constraint where you have been told that mass small m, which is constrained to move in that vertical direction because of this slot, and this wedge obviously will move in the x direction. And you have to find the accelerations of both these masses. So how do you go about this? So first you will write your normal NLM equations, and then you will need another wedge constraint equation which will relate the accelerations of capital M and small m. So let's try and write that relation. So let's assume that this guy is moving down with some acceleration a1, and let's assume that this wedge itself is moving in this direction with an acceleration a2. So what you need to do is we will take a look at the rod from the reference frame of the wedge. So let's see what we see there. So from the reference frame of the wedge, you will realize that this rod has two accelerations. Okay, so acceleration of rod as it will appear to you would be something like this. Let's draw ourselves rod first. Here is the rod. It already has this acceleration a1, and now it will have another acceleration a2. And you know that the resultant has to be in this direction, which is along the incline. Okay, so the angle with the horizontal would be alpha. Okay, so from the reference frame of the wedge, AR can, or rather should point down the incline. Okay, so as I said, in the reference frame of the wedge, the motion of the connected block or object can only be either up the incline or down the incline. So in this case, we can clearly see it is coming out to be down the incline, so that I can say that the angle that the net acceleration makes with the horizontal is alpha. Okay, so I can now conclude that therefore AR makes an angle alpha with the horizontal. Okay, now once I've figured that out, now writing the relation between A1 and A2 is very, very simple. I know that I had two accelerations. Okay, here was A2, here was A1, and the vector sum of these is AR. And since this was alpha, this would also be alpha. So what I can see from this triangle, vector triangle, is that tan alpha would be equal to A2 over A1. Okay. So I can write hence tan alpha equals, okay, A2 over A1. Now this is what we are going to call the wedge constraint equation. Okay. So remember that this is always going to be the basis of a wedge constraint equation. You identify the directions of the block and the wedge, and then look at the acceleration of the block in the reference frame of the wedge. Note that this direction will be up or down the incline, and write an equation which is telling you that, and that equation is the wedge constraint equation. So if you want, we can take up another example, by the way. So this was a simpler example where small m has to move in vertical direction. So you may have seen this many times. So how about a general example? Let's talk about a general example. So in general, this is the one of the toughest cases that you may have. So imagine that this guy is here and it has a block kept on this, like this. Now both of them are free to move, let's say. So this is another example that I'm showing you. So in this particular case, what happens is that your block may move in the x direction as well as y direction. Yes, Suraj. So how do you write the accelerations here? Now here you will realize that this block will have two accelerations. So let's call them A1x and A1y. And then let's imagine that your wedge has an acceleration in the opposite direction. And let's call this A2. Okay, so in that case, what will you do here? Now again, the trick is always to go to the reference frame of the wedge. So from the reference frame of the wedge, what will you see? What is the acceleration of, let's say, what is the acceleration of 1 with respect to 2 vector? Let's see how that appears. So that will appear to you as, it will have a y acceleration which will be a1y, and then in the x it will have two components, a1x and a2. Correct? This would be the resultant. This would be the resultant vector, which we are calling it here. Okay, now that you see this vector, again, this vector has to point along the incline. So if the angle of inclination here was theta, then you will realize that this becomes theta, this also becomes theta. So here the wedge constraint equation would be, therefore, I can say that tan theta would be equal to a1y over a2y, oh sorry, a1y plus a2, a1x. So in this particular example, this would have been your wedge constraint equation. So I hope you get the idea. So this is how you can easily write your wedge constraint equations. So there will be one equation which will relate the different components of the accelerations of the two blocks connected, or whatever body is connected or moving in contact with the wedge. Okay. So if there is any doubt about any this how I got this equation, then let me know. Otherwise, we can move forward. Okay. Is that clear? Just go over this quickly and let me know. So this I think is one of the trickiest examples that you may encounter. Others would rather simple. As I said, how do you write the constraint equation? Very easy. Just identify whatever restriction is there in the motion of the block. Okay, so that's it. All right. So moving forward, now we will talk about pseudo forces quickly. So what are pseudo forces? So as we had learned initially that there are two categories in which we divided our reference frames: inertial and non-inertial, right? So inertial reference frames were those where law of inertia holds true, where without a force you cannot see an acceleration. Okay, so that is what an inertial reference frame is called. Okay, and now Newton's laws are only strictly valid in inertial reference frames. So as I said, a reference frame in which Newton's laws of motion are strictly valid is called an inertial reference frame. Now, a reference frame which accelerates or rotates with respect to an inertial reference frame is called a non-inertial reference frame. Okay, and in this reference frame, Newton's laws stop being valid. Okay, uh, we had already discussed this. So you cannot use your Newton's laws in non-inertial reference frames. So, but sometimes you may get stuck in a situation where you are in a non-inertial frame and you want to analyze the system. So, how do we do that? So for that, we make a small mathematical tweak. Okay. So, to use laws of motion of any object on any object in such a reference frame, that is, in a non-inertial reference frame, an additional imaginary force is applied on the object. Okay. Now, this additional imaginary force is called a pseudo force. Okay. That is what we are talking about. So, pseudo forces are nothing but additional imaginary forces that you apply on an object in order to explain their motion from a non-inertial reference frame where F equals ma equations would not have worked. Okay, hello AA, how are you? So, please remember these are imaginary forces. So, however, these are imaginary forces, but they can feel very real. Okay, so how do you know that they are imaginary forces? Because they do not have any reaction pairs. Please remember, if you feel a force, if you feel a force, and if you want to judge that whether it is a real force or an imaginary force, the easy way to do that is look for its reaction pair. Okay, if you can find its reaction pair, it's a real force. If you cannot find its reaction pair, it has to be imaginary. Okay. Now, these are only applied, you will only apply such forces in a non-inertial reference. Okay. This force is calculated as follows. This F pseudo is uh, minus times MA observer. Okay, I hope you remember. This is a quick revision, so I'm just quickly telling you. If you add this imaginary force to your all your real forces, then your F equals MA equations seem to be working again. Okay. Want video on a relative angular velocity? Okay, so first of all, okay, okay. Why do you need a video on relative angular velocity? Relative angular velocity would only come in rotating reference frames, right? Rotating reference frames are not in your syllabus. So whenever you're talking about relative angular velocities, it's going to be rather simple. Either you will have two objects which are rotating in the same direction, okay, with omega 1 and let's say omega 2. In that case, it will be omega r would simply be omega 1 minus omega 2. Or you can have two objects which are one is rotating like this and with omega 1 and another is rotating in the opposite sense with omega 2. So in that case, omega relative would be omega 1 plus omega 2. That's about it. The only relative angular velocity questions that you will have will be of these two kinds. You will not have any other kind of relative angular velocity questions because rotating reference frames are not in your syllabus. Okay. All right. So here, please remember, m is the mass of the object being observed, and a naught is the acceleration of your observer or your reference frame. Okay. Now, as I said, these forces do feel real. In fact, this was a consequence in Einstein's general theory of relativity that pseudo forces, the way they feel, though they're not real forces, they don't exist, but they give you a feel of a real force, and that feel is indistinguishable with the force of gravity. So any pseudo force feels exactly like the force of gravity. Okay, so they can feel very real. And when do we apply them? We apply them in non-inertial. So let's take up an example. So this was a question that was asked in JEE Mains 2005. Okay, so it says a block is kept on an inclined smooth surface which has an angle of inclination alpha, as you can see in the figure. The incline is given an acceleration a to keep the block stationary on the incline. Then a is equal to. Okay, so quickly try this. Now every or almost every problem in mechanics can be solved using the analysis in the reference frame of ground, okay, or an inertial frame. So the concept of pseudo force is not really compulsory to be understood, but it will just make your life easier. Okay, so it's just an alternate way of solving problems from non-inertial reference frames. That's about it. Okay, so let's quickly solve this. Okay, a dash. All right. So I hope you guys are trying this problem. So as I told you in this quick review series, I will be not only discussing theory, I will also be taking up previous year JEE questions, JEE mains questions, especially because the JEE mains people have the habit of repeating them. So make sure that you're not only quickly revising a theory, you're also practicing these questions. Practicing these is very important. Okay, so Suraj says, see, the relative angular velocity is not there in which class? In which class? It is not there in IIT JEE syllabus. Uh, uh, I'm not talking about relative angular velocity, but see, relative velocity or relative acceleration, when do they come into play? When you're moving into a translating frame, a reference frame that is moving, right? Then you need relative velocity. When you switch the reference frame from the ground frame, so similarly, you would need the idea of relative angular velocity when you move from ground frame to another rotating frame, right? Rotating frames are not in your J syllabus. Okay, so Suraj says, see, let's see. So this is very simple. What you need to do is there are many ways to solve this. One way is in the to solve it in the reference frame of the wedge. So in the reference frame of the wedge, since the wedge was moving forward with an acceleration a, what you will see the block to be doing, you will see an additional force of ma acting on the block like this. So it will have a pseudo force of ma. Then it also has some n, okay, so which is acting this direction, and then of course it has mg acting in this direction. Okay, so these are the three forces that you will see acting on the block in the reference frame of the wedge, right? And you've been told that the block is stationary on the incline. So in this reference frame, the block will appear stationary, which means it is in equilibrium, which means these two components of ma and mg would be balancing each other. So this component of mg would be mg sine theta, and that component of ma would be ma cos theta, right? This would be theta, so that will be ma cos theta, and similarly, this would have been theta, so that would have been mg sine theta, right? The question will not come from here. Okay, so as I told you, a very, very simple case may come. Very, very simple case may come. So either you have two objects which are rotating in the same direction, or two objects rotating in the opposite direction. In both these cases, the relative omega can be said as either omega 1 minus omega 2 or omega 1 plus omega 2. They will not ask you cases which are more complicated than this. That is all I'm saying. See, technically, omega is a vector quantity. So you could have had one thing which is rotating in this plane, so having an omega in this direction, another thing rotating like this, having an omega here. So you could have been asked the relative omega of these two also, right? With two omega vectors pointing in different directions. Okay, but that is not in your syllabus and that won't be asked. So in the reference frame of wedge, block is in equilibrium. So therefore I know MA cos theta would be equal to mg sin theta, and therefore A equals g tan theta. So that is the way you could have solved this using the idea of pseudo force. And yes, Suraj, nicely done. G tan theta, C is the answer. Okay, let's quickly take a look over another question. So here we've been told that a spring balance is attached to the ceiling of a lift and a man hangs his bag on the spring balance, and the spring balance reads 49 newtons when the lift is stationary. If the lift starts moving downwards with an acceleration of 5 meter per second square, the reading in the spring will be. So what will happen to the reading of the spring balance when the lift starts to go down with an acceleration of 5 meter per second square? So very simple one. Let's quickly get the answer. Hurry up. So again, these kind of this question is supposed to be very easy, very simple, straightforward. So if you know your basics, trust me, mains would be easy to crack. To crack mains, all you need is basics, speed, and accuracy. That's it. If you got your basics right, then all you need is your speed and accuracy. Okay, so can we have an answer for this quickly so that we can move forward? Nobody has an answer to this. Okay, that's strange. This is probably one of the simplest problems that you'll come across. Okay. So when your reference frame is moving downward with an acceleration, you will have a pseudo force acting upward. Okay, so on the bag, you will have mg, you will have ma, and you would have had spring force kx. Okay, so spring force would have been mg minus ma. So that would have been mg, you have been told is 49, I think. And ma would be, so mg is 49 because when this lift was at rest, then the spring would have read the weight of the object. So from here, m would have been 49 by 10 into 5. This is the answer that you should have gotten. That'll be 49 by 2 or 24.5 Newton. Okay, so this is the answer which is closest to our. This is the option that's closest to our answer. So this will be the right option. Okay, very simple. Okay, now let's quickly talk about friction and how do we solve problems with friction. So what do we know about friction? So friction is a contact force. Yes, Suraj. Yeah, but you can't be taking that much of time for this kind of problem. This is a super simple problem. Okay, so you should have been quicker. As I said, mains cracking mains is all about having your basics right, very basic, right? You don't need to be very good at very solving very tough problems. If you have your basics right, and if you have good speed and accuracy, then that is it. So if you're taking that much time to answer that kind of question, then trust me, your speed is not up to the mark. So again, let's talk about the properties of friction force. First of all, it is a contact force. It is electromagnetic in nature. It always acts tangential to the common contact surface. If there is slipping, friction acts in the direction opposite to that of relative slipping. If there is no slipping, friction acts in the direction needed to prevent slipping. It is a non-conservative force and causes dissipation of energy. And the direction in general would be to avoid, prevent a slipping or tendency of slipping. So that is. Then we also realize that this is the graph that you would have gotten if you would have applied a variable force on any object. I'm not going over how we get this graph. This is an experimental result that you get. So based on this, you will realize that friction behaves differently in two different situations. So up to the mark when slipping has not happened, it behaves differently, and after the slipping has started, it behaves differently. So this friction is called static friction up to the point where the slipping has not started is called static friction, and once the slipping starts, you notice a change in the behavior of friction force, and hence this kind of friction is called kinetic friction. Okay, now you will realize from the graph a few things, that the static friction can change its values. However, it can only achieve a maximum value called the limiting friction. However, kinetic friction has a constant value always. So let's talk quickly about static friction and the kinetic friction. Okay, so I think here do I have the same? No. So let's quickly talk about the static friction first. So static friction, you realize from the graph, is a self-adjusting force. Okay, this is a self-adjusting force and can take up any value from 0 to a maximum value called limiting friction. How much value it will take? It will take the value which is required to prevent slipping. So please remember, the aim of friction is to prevent any kind of slipping. So static friction will take up any value which will prevent a relative slipping between two surfaces. Okay, relative motion between two surfaces. It does not oppose motion, it opposes relative motion. Friction causes motion at times. Okay, so please remember that. Okay. Now we'll talk about laws of limiting friction. Laws of limiting friction are as follows. So one, this force is independent of area of contact. Then it is directly proportional to the normal reaction between the two contact surfaces. So you can write that Fs max, which is the maximum static friction, is directly proportional to N. Therefore, I can say that the maximum static friction or limiting friction is equal to mu s times N, where mu is the proportionality constant that you introduce, and it is called the limiting friction coefficient of limiting friction. This is called the limiting friction, and mu is called the coefficient of static friction. Coefficient of static friction. Okay, and the value of mu depends purely on the nature of the two surfaces in contact and can only be determined experimentally. Remember this. Then let's talk about kinetic friction, and yes, so let me just correct that. This should be kinetic friction. So this force is always has a constant magnitude. Okay, very simple. Uh, so this force has a constant magnitude. Then there are again three laws of kinetic friction. The first one says that it is independent of area of contact. Second says it is independent of relative velocity of motion. So practically this is not true, but theoretically we treat the kinetic friction to be independent of relative velocity, which means if slipping is happening, if suppose this guy is slipping very slowly, then then the kinetic friction acting would be same as if this guy was moving very fast. In practical life, however, that is not the case. In practical life, it may change. But again, you don't need to bother about that. Okay, in your syllabus, you only consider this to be a constant force. Now, again, the value of the magnitude of kinetic friction is also directly proportional to normal reaction between the two contact surfaces. So you can write this, and hence you get an equation of kinetic friction equals mu k times n, where mu k is another constant, proportionality constant, which you call coefficient of kinetic friction. Both mu k and mu s are the unitless constants. Now, you also talk about angle of repose. So, what is angle of repose? Angle of repose is defined as the minimum angle of inclination of a plane with the horizontal such that an object placed on it will just slide. Okay, so the condition for slipping would happen at, if the condition for slipping, just slipping happens at some theta equals alpha, then alpha is called the angle of repose. So this is a experimental way of finding the coefficient of friction, by the way. So what you do is, when you keep a block on an incline, you keep increasing the angle of the incline at some theta, it will slip. That angle is called angle of repose. And the idea of telling you angle of repose is that if I tell you the angle of repose, you will be able to determine the value of mu s. And this is how. So mu s and angle of repose are related like this. So coefficient of static friction is equal to tan. Okay. Now in problems you will realize. Okay, so this is also somehow sometimes also called angle of friction, but the definition varies. But angle of friction and angle of repose both always have the same magnitude, and both are equal to tan inverse mu. Okay. Now, as I was saying, practically you would have noticed that since the variation of the forces is like this, so you will realize that limiting friction, you will realize from the graph that practically limiting friction is always greater than equal to kinetic friction. And limiting friction is mu s n, which is always greater than equal to q k n. So, for practically for most of the objects, your mu s is always greater than equal to mu k. However, in your questions, they can be given to be equal. Okay. Oh, that is so sad, Ananya ji. How did that happen? Was he like really old? However, in most of the problems, in most questions, so either in the question they should give you the mu k and mu s separately. If they don't give you those separately, then you assume them to be equal, and they will be represented as simply mu. Coefficient of friction is defined for two surfaces of contact or for each surface. No, for a pair of contact surfaces. It is defined for a pair of contact surfaces. Okay, Suraj, for two surfaces. Okay, so for example, let's say between my hand and this pen, there will be one coefficient of friction. Between my hand and this glass, there will be another coefficient. Oh, that is so surprising. That is so surprising. Oh, and really sad. Now, that is a very, very young age to have a heart attack. Okay. That is strange and very sad. Sorry to hear that, Ananda. Okay. So let's move forward with our discussion again. Again, you guys also should be taking care and stay safe. Stay at your home. Make sure that you're just being safe. Again, so how do you go about solving problems including friction? So this is the standard checklist that you should follow. So first you need to ask whether there is slipping or not. So in case there is slipping, if yes, then you already know In this case, direction and magnitude both are easily known. Right? You know that the friction acting is kinetic, and if the friction is friction is kinetic. That's all right. That's all right, Ananya. It's okay. Okay, don't worry about it. Okay. So as I said, the direction of kinetic friction is always opposite to relative velocity. Okay. So for instance, what do I mean by that? So when I take this glass, and if this glass is moving in this direction with respect to my hand, then the kinetic friction would be acting in this direction. If this glass starts to move in this direction, then the kinetic friction will act in the opposite direction. Now, even if both of these are moving, so suppose the glass is moving like this and my hand is moving like this. Okay, so imagine that kind of motion. Okay, something like that happening. So with respect to my hand, how is the glass moving? So glass is moving like this and glass is moving like this. So glass is moving somewhere like this in the reference frame of my hand, right? So this is the direction of relative motion. So on the glass, the kinetic friction would have acted in the direction opposite to that relative motion. Okay, so please remember that kinetic friction always acts opposite to the direction of relative motion of the two bodies in contact. Okay, again. So if there is slipping, then you know friction is kinetic. You know its direction, as you can see the direction of relative motion, and you also know the magnitude immediately. It has a constant magnitude of mu k times n or mu times n if single mu is given. The things become tricky when there is no slipping. Okay. Also, when there is situation which is just about to slip, if you've been told that just about some object is just about to slip, then the magnitude of friction in this case is known that it will be limiting friction. Please remember that is the condition for just slipping. That friction would become equal to limiting friction. Okay. And then there is the most complicated case where you've been told that there is no slipping. So in case of no slipping, the magnitude of friction can be determined using F equals ma equations. Please note this is static friction, and static friction can lie anywhere from 0 to limiting friction. Okay, so please remember this. So in case there is no slipping, the friction acting would be static, and that can have any value in this entire range. So you cannot pre-decide the value. How will you judge the value? You will write F equals ma equations to ensure no slipping. You will assume no slipping. To ensure this, you will assume a value of friction. You will calculate that. Okay, and that should lie in this range. Okay, and that is how we can find the value of static friction. Now, if the condition is for just about to slip or no slipping, then sometimes judging the direction may be difficult. Okay, because in a relative slipping, you immediately see where things are going. But if there is only tendency of slipping, so sometimes you may not be sure of, if I tell you that this guy has a tendency of slipping, you don't know whether it is slipping in this direction or in this direction or in this direction. So how can you quickly and easily correctly judge the tendency of slipping? So direction of friction is opposite to the direction it tends to slip, and to judge this direction, you find the direction of motion without friction. So you imagine if friction had not been there, okay, so you can imagine all your surfaces to be frictionless, and then how would they have moved? Okay, the direction in which any object would have moved in absence of friction would be the direction of tendency of slipping in presence of friction. So that's the easiest way to judge this direction. All right. So a lot of questions have been asked from this topic in mains. So why don't we get started and have some practice of these? Okay, so here is a question that you should be trying. This was asked in JEE 2019. Okay, and in this question, you've been told that a block of mass 10 kg is kept on a rough inclined plane as shown in the figure. Okay, now a force of 3 Newton is applied on the block, and the coefficient of static friction between the block and the plane is zero point 0.6. So coefficient of static friction has been given to you. Okay. Now, what should be the minimum value of P such that the block does not move downward? Try and answer this quickly. Okay, let's quickly try this. Hurry up, try this. This was asked very recently. Okay, get yourself some practice. Quick. So in this question, it would be very easy to judge the direction of tendency of slipping. What is the direction of tendency of slipping? It will be downwards. Okay, and if the direction of tendency of slipping is downwards, the force of friction would be acting upwards. And what is the condition told to you? That you have to find the minimum value of P that the block doesn't move. So just slipping condition you can imagine. But just slipping condition, you also know the magnitude. Okay, what is the magnitude? This is limiting friction should be equal to mu times n. Okay, so now you can find the answer, and the answer would tell you that if you draw the FBD of this block, the forces that this is experiencing, here it would have 10 or 100 sine 45. Here you would have had 100 cos 45, and then you would have had n. And n would be equal to mg cos theta. Okay, this is very easy to find. So I can say that P to 3 plus 100 sine 45 should be equal to P plus mu s. That's it. That is how you would have solved this. Okay. P plus 100 sine 45 equals P plus what was mu s? Mu s was 0.6. Yeah, 100 cos 45. And that will give you P equals P plus 100 by root 2 into 0.4. 40 by root 2. P plus 40 over root 2, or I can say P equals P plus 20 root 2. Okay. So root 2 is 1.4, 1.4. So I can say this is roughly 3 plus 20 into 1.4, which would be, so 20 into 1.4 would be 28, 28. This would be around 31. Let's see if we have that option. Yes, this is the option that is closest to my answer. Okay, yes, so well done, Suraj. Okay. All right, let's take a look at another question which was asked in JEE Mains 2018. So here you've been told two masses M1 and M2. So here you've been told two masses of M1 and M2, M1 being 5 kg and M2 being 10 kg, okay, are connected by an inextensible string uh, over a frictionless pulley. Good evening, Aftab. How are you? Okay, they are moving as shown. You've been told if the coefficient of friction of horizontal surface is 0.15, the minimum weight M that should be put on top of M2 to stop the motion is. Okay, so what is the minimum weight of M which is required to be placed on M2 which will stop the motion? Okay, so let's quickly get this one. Okay, so try this quickly and let me know your answers fast. So make sure that you are attending these videos and you're solving all the problems. You are understanding all the concepts, revising all the concepts, getting some practice of the mains level questions, previous year questions. And after you have done this, what you should be doing is you should be picking up any standard question back from the market and solve mocks and work on your speed and accuracy, because that is the next step if you want to do well in mains. As I said, one is having your basics right, having some practice, just some idea about mains level questions. They are usually easy only. There shouldn't be much problem here. The differentiating factor would be about speed and accuracy. Okay, I think most of the people, if given enough time, would be able to solve a lot of questions of mains. The only thing that differentiates the top rankers from people who do not perform that well is the number of attempts. Trust me, even with such easy problems, because of the time, most of the students are able to attempt only 60% of the paper. That has been my experience. Okay, so if you can work on your speed, if you can attempt at least 90% of the paper, automatically you will get a better rank. Okay. Okay, so anybody solving this, okay, think about it. What must be happening? So if you kept M here, 10 kg was here. So the N from the ground would have become N would have been 10 plus M times G, correct? And you have a force which is trying to move. Okay, so this is what 5G acting here, and you would have had a tension acting here, and then you would have had a friction acting. So since you have to find the minimum weight M. So for M to be minimum, again you will go back to just slipping condition. For small m to be minimum, we consider the just slipping condition. So if the condition is of just slipping, then you already know what is the force of friction. Force of friction is limiting. I told you. So therefore, what we will have is, hello Soham, how are you? Therefore, you will have that mu times n, which should be equal to t, which should be equal to mg or 5g. Okay, so therefore you have what was mu? Mu was 0.15. 0.15 times 10 plus m times g should be equal to 5g, will get cancelled, and what you will have is 10 plus equals, you would have had 500 over 15, so that would have gone by 100, and here you would have got 3. What you get is m equals 70 over 3. That is what you would have gotten. Yes, 23.33. That is absolutely correct. However, none of my option is that. So now what? Now what? Now you find the closest answer. Okay, so Suraj has given the right answer. Yes, 23.33 is the minimum M required to stop any kind of slipping. But then what has been told? What is the minimum weight? So in the options, what is the minimum weight which would be able to stop the motion? So the correct answer is B. Okay. Option B is giving you the minimum weight which will be able to stop the uh, slipping from these options. Okay, out of these options, this would not have been able to prevent slipping. This would not have been able to prevent slipping. Only these two forces could have prevented any kind of slipping. Out of them, the minimum force is LB. Okay, so I hope you guys followed the logic of this. Okay, now let's move on to the next one. Then. So here is another question that you can try. Okay, so this was again asked in JEE Mains 2015, and this question says that given in the figure two blocks A and B of a weights 20 Newton and 100 Newton respectively. Okay, now these are being pressed against a wall by a force F, as shown. If the coefficient of friction between the blocks is zero point 0.1 and between the wall is and the block B is 0.15, then the frictional force applied by the wall on the block B, that is what you find. Okay, let's find this very quickly. So this is a very nice twist in a very famous popular question, standard question that was asked in JEE Advanced. The Mains people added a small twist to that. Okay, so what will be the answer of this? Again, to answer these questions correctly, or any of the Newton's laws questions correctly, the key is to make the right FBD. Always try start solving a question by making the FBD. Okay, so try and quickly solve this. So what do you think will be the answer for this? Hurry up. Again, I think you shouldn't be taking more than 2 minutes for any of these questions. These are mains level questions. Uh, all of them should be solved within 2 minutes. Okay. Again, in case you're taking more than 2 minutes to solve any of these, then you need to work on your speed. Okay. Ideally, I would want you guys to solve all the mains level problems uh, in an average time of 1.5 minutes. That's it. So try aiming for that 1.5 to 2 minutes. Yeah, somewhere between that. That would be the ideal scenario. Okay. Suraj, could you find the answer? So AP says C. Okay. 100 Newton. So read the question carefully, AP. You have been asked the frictional force applied by the wall. Okay. So 100 Newton is not the correct answer, by the way. Okay. So let's see. Let's see. Again, as I keep telling you, always start drawing by the FBDs. Okay. So how about the FBD of A? So if I draw the FBD of A, so how does that look like? FBD of A. So again, A over this, you had some force F acting on. Okay. The block B would be applying some normal reaction, pushing it away from itself. Let's apply this. Then you would have had mg would have been acting downward. Now, because of this mg, this guy A would have had a tendency of slipping downward. Okay, so it would have had a friction force acting upward. Call that F1. Correct? Got it? This is how the FBD would have looked like. Mg, okay, I already know as 20 Newton. So 20 Newton. Okay. Now you will realize if I draw the FBD of B, how does that look? So here is your B. So you realize two forces out of the four forces I've shown in the previous diagram are appearing from interaction between A and B, so they will have their reaction pairs. So if B pushed A with N towards the left hand side, A would have been pushing B towards the right with the same N. This guy would have felt some N from A, and then it would have also experienced some N, let's call that N dash from the wall. Okay. Next, it would have felt its own mg, which we can call mbg, which you know is 100. Then, if B applied a friction on A, which was upward, so A would have applied a friction on B, which would have been downward. So you realize it would have been an F1 force in the downward direction. So friction from A on B would have been in downward direction. Now you realize there are two forces in the downward direction, and to balance this, the friction from the wall must come in the upward direction. This is the friction from wall F2. Okay. Now, once that I have made the FBDs, now this problem solving is very, very simple. Okay. I can write for equilibrium of A. Can I say that F1 would be equal to 20 Newton? Okay. Just by writing from the equilibrium condition. Also, for equilibrium of B, what can I say here? That all the this force, upward force F2, should be equal to F1 plus 100. F2 should be equal to F1, which is plus 100. F1 I see from here is 20. The answer is 120 Newton, in fact. Okay. So that is one way of doing this. You could have done it in a shorter way also. Okay, so please remember that. Don't forget to find the shortest ways. So you know if both the blocks are in equilibrium, then I can take both of them as one system. If you take both of them as one system, then you could have gotten your answer by drawing a single FBD. So if you would have drawn this system, then this system would have felt this force F from here, some force N dash from the wall. It would have felt a net force of 120 Newton downward. So all this weight would have been balanced by the force F2 by the wall. So from here you could have directly noticed that F2 would have been 120. Okay, got it? Is that clear now, AP? Okay. So please remember there are two ways of solving this. Either you could have drawn the FBD of one A and B separately, or you could have just drawn a single FBD of the combined system of A and B. I keep telling you this. Remember this. As long as any constituent masses of my system move with the same acceleration, which may be zero also, then in that case you can take them in one single system. Okay. All right. If that is clear, let's move on to the next question then. This question was asked in JEE Mains 2014. This says a block of mass m is placed on a surface with a vertical cross section given by the equation y equals x cube over 6. Now, if the coefficient of friction is zero point 0.5, then you have to find the maximum height above the ground at which the block can be placed without slipping. Okay, try this. And let's see a quick answer from someone. Quick and correct both. Okay. Suraj gave a correct answer, but he took too much time. AP gave a relatively quick answer, but the answer is not correct, unfortunately. So let's try and have an answer which is both quick and correct. Okay. Let's see who will give me that answer. Okay. Are you guys even trying? Or is everybody quietly waiting for me to solve? So guys, this is about your own practice. Okay, now don't wait for me to solve. Give it a shot on your own. Try and solve all these problems on your own. You're the ones who are going to be taking the JEE exam soon. I took my JEE exam long time back and I have already cracked it. Me practicing more will not help you. Me solving more questions will not really help you much. Okay. Let's see. Go on. This is a slightly tricky problem, but that doesn't mean it should scare everybody away. Okay, so the equation of the cross section is given to you y equals say. What is happening is that the slope of this cross section is constantly changing, right? You can think of this as an incline whose slope is constantly changing. So for any y, the slope for tan theta would be equal to dy over dx, which is equal to x square over 2. Correct? So at every x, the slope of your incline becomes x square by 2. I know for just slipping. Or as long as there is no slipping. So let's write that for no slipping. You can say that tan theta should be less than equal to mu. Okay, I hope you remember that. What was the coefficient of friction? The coefficient of friction was zero point 0.5. Okay, so I can say that tan theta is also equal to x square over 2 should be less than equal to point, which means x square should be less than equal to 1, or I can say that x should be less than equal to plus minus. Okay. So the corresponding value of y would the maximum y would be at x equals 1 or y equals max plus 1 and y max. How much will that be? 1 over 6. That is how you could have found the maximum height to which you could have placed this block to ensure that it does not slip. Option A is the correct answer. Okay. So this problem does seem a little tricky in the first go, but when you think about it, this is based on standard principles. Okay, so nothing too complicated about this. Don't worry. All right. So here is another question. So this question was asked in JEE Mains 2005. Okay, a smooth block is released from rest on a 45-degree incline and then slides it down a distance. It slides a distance d. The time taken to slide. Okay. Okay. So first, a smooth block was released. Okay. Now the time taken by the smooth block to slide turns out is n times the time to slide on a rough incline. Okay. On a rough incline is n times the time taken by the smooth incline. You can find the coefficient of friction. The language is slightly, I don't know, improper. I think so. That also happens in mains at times. Okay, so let's try and go over the question one more time. This says a smooth block is released at a rest on a 45-degree incline and then slides a distance d. Okay, happening. Now the time taken to slide in is, well, it should be is. Time taken to slide is n times as much to slide on a rough incline as done on smooth incline, and then find the coefficient of friction. Okay, so I think what it is trying to say is that you consider two situations. You consider two situations. You have two inclines, identical inclines. Okay. Now one is rough, one is smooth, and in both the conditions you have a block which has to slide down a distance. Okay, I think yeah, that is the case. It was released, so it will slide down only. So the idea is if this is smooth, so here the block would have come down quicker, right? Would have moved faster. And let's say to come down to a distance b, say that to come down to a distance, it takes a time t1. And in the other case, let's imagine that this incline was rough. And with the rough incline, it takes a time of t2 to come down a distance d. So obviously rough, it will move slower, so the time taken would be more in the rough one. And what the question essentially is trying to tell you is that if T1 or T2 equals n times T1, find mu. Is what the question is trying to say. Okay, so let's just quickly solve this. So I know on a smooth plane, So this is my case A, case B. So let's try and talk about case A. In case A, I know the acceleration. Acceleration would be g sine 45. Okay, so in traveling at distance d, time taken d1 square half into g into 1 by root 2. Okay, that is g sine 45. That will be the acceleration, right? So all I'm doing is I'm applying s equals ut plus half a t square. So I would have gotten this. That would have been my first equation. Similarly, for case B, the equation that I would have had would have been half times g sine theta minus mu cos theta. So I can take g sine theta cos theta common because of 45-degree angle, and inside I'll have 1 minus mu uh, into t2 square to t2 square with again. Now all you need to do is divide equation number 2 by 1. Let's see what you would have gotten. So these things, half g over root 2, those would have gotten cancelled. On one side, you would have had 1 minus mu t2 over t1 whole square would have been equal to 1. And this you already know is n square. Say 1 minus mu equals 1 over n square. And from here, you would have gotten that mu equals n square minus 1 over. That is the answer that you should. Let's see if that is anywhere in our options. Yes, it is. Okay, and what kind of friction am I talking about here? This would be mu k, right? Why? Because the slipping is happening. Slipping is happening, then the coefficient of friction would be mu k. So this is my correct answer. Okay, equals 1 minus 1 over n square. Okay, I hope everybody followed this. If you didn't follow this, you can let me know in the chat. Okay. Let's move on to another question. Okay, so this question has not been asked in mains, but this is a slightly tricky problem, and this is one of my favorite problems. So I always like to ask this question in every class that I teach. So be it 11th, be it 12th revision or 12th pass. So I always give this question. You've been asked, block is kept at a rest on a horizontal surface. If the coefficient of friction between the block and the surface is mu, then what is the minimum force required to move the block? Okay, let's quickly try this. Okay, and then I think, yeah, this is the last question that I had for today. I think yes. Then we will wrap it up. To try this, I will give you 2 minutes to give this shot, and then I'll discuss the solution. Okay, so let's try and answer this very quick. Okay, so any answers, any attempts so far? Does anybody like to give the answer? Okay. All right, so no answers. So okay. The reason why I was giving some time was I wanted you to figure this out on your own, but since nobody seems to be doing that, let's discuss the how you do that. So the trick here is that a lot of people don't realize is that a lot of people write the answer immediately, which thankfully you guys didn't do. So most of the people write the answer immediately and they give the answer as UMG. That is wrong. Why is that wrong? Because it never says in the question that the force has to be horizontal. You just asked about the minimum force required to move the block. So you assume that your force F is acting in some direction which is at an angle of theta. If that was the case, then you would realize a force of friction would have come into play in this direction. You would have also had two more forces of mg and n, okay, acting in the vertical direction. Okay, so now for a just slipping, I immediately know what is my friction. Friction has to be equal to the limiting friction. So I can say that okay, so this is my y direction and this is my x direction. So for a y direction, the equation for equilibrium that I can write is that n plus f sine theta will be equal to mg. Right. So from here I will get n equals mg minus f sine theta. Right. Also for x direction I will have that f cos theta equals mu times n. Okay, I hope you guys can see that. What will that give me? That will give me f cos theta equals mu mg minus mu f sine theta. So I can take out f common from here. I will have had cos theta plus sine theta equals mu mg. So f is coming out to be mu mg over cos theta plus mu sine theta. This is the expression that you would have gotten for f for different thetas. Now for minima, all you need to do is differentiate with respect to theta and find the answer. So I can say for f equals minimum, what do I want? I want the denominator to be maximum, correct? Cos theta plus mu sine theta to be max. And I hope you guys remember the value of maximum value of a cos theta and plus b sine theta. If you don't, then this is what it is, and you should remember this. So a cos theta plus b sine theta is always less than equal to root of a square plus b. So remember this. So therefore, the maximum value of a cos theta plus b sine theta is always root of a square plus b square, and here a is 1, b is mu. So here you will realize, therefore f min would have been mu mg over 1 plus mu squares root. Let's take a look, and first of all, let's see if we have if the options matching with that. Yes, we have. Option D would have been a correct answer. Just take a quick look at the solution and let me know if you followed every step. Okay, if there is some part that you did not follow, then you can let me know and I will go over that one more time. Okay. Okay. So all clear. So now, as I said, we have discussed all the key concepts of Newton's laws of motion. We have also talked about some previous year questions, which should have given you some idea about how JEE mains questions are asked and how to approach them. Now all you need to do is get some of your own practice. Make sure that you're solving problems at a good speed with a good accuracy. Okay, you do that, and trust me, you will do very well in. Okay. So that is how that is where I would like to wrap up today's session. Now, before I take your leave, let me remind you that you should be getting your uncapped subscriptions if you haven't gotten them already. And this is how you do it. Go to the plus section of your app, select your goal as IIT JEE, and click on that gets us button. All right. So when you click on that get subscription button, you will be redirected to the payment page where you will have a box, and in this box would have said, "Do you have a code?" Okay, so in this box where it says, "Do you have a code?" This is where you want to put my code RD Life. If you put this code, you will get a 10% flat off on all these fees. So hurry up, get the subscriptions, use the code RD Life, click on proceed to pay, and get enrolled in any of these courses. Okay, so once you've gotten the subscription, these are the ongoing courses. So there are 3 ongoing courses for class 11 topics, okay, and 4 ongoing courses for class 12 topics. Okay, these are being taken by the J English team. Okay, so you can get yourself the subscription, enroll in these courses very fast. Again, if you like today's video, then don't forget to press the like button and share it with as many people as you can. As we keep saying at Unacademy that we know that all the students cannot afford this subscription. Those of you who cannot afford this subscription, Unacademy is providing you also a chance to learn from the best teachers and learn it for free. Okay, so that every student gets the opportunity, make sure you guys who are watching this are sharing with all your friends. Okay. Don't forget to press the bell icon, okay, and to see keep receiving all the notifications of all the lectures and sessions happening on this channel. PDF notes of the slides used in today's lecture would be available for download. Again, those of you following us on the YouTube channel of J English should be connecting with us on the Telegram app using this link so that you're not missing out on any of the amazing content that you get here on the J English channel. Now, before I leave you, before I take a final leave, let me remind you one last time. This is my code RD Live. So if you like my lectures, if you'd like to enroll in my courses, if you would like me to be your mentor for your next JEE exam, then you can get yourself the Unacademy subscription using the code RD Live and enjoy a 10% off subscription. Right. So with that, I will take a leave. Now tomorrow I will come back with another quick review session, and tomorrow we will start discussion on work power energy. We will look to finish the work power energy discussion also within 2 sessions, just like we could manage with NLM. Okay, so the idea is going to be this only. We will try to quickly wrap up all the topics within 2 sessions each. Okay, so, yeah, I'm not. All right, so that is it from my side for today. I'll see you next tomorrow. So till then, you guys take care of yourselves and keep practicing.